Okay, what's up? Is everyone awake? Is everyone ready to not be here and to be downstairs? Fab. Okay, I'm going to do my level best to make this quick, sharp, and short. Right. Anyway, what's up? My name is Chris. I'm the Chief AI Officer at a company called Cloud Lighthouse, where Andrew and I both work. So we get to run around and tell people that AI is more important than your firstborn, oxygen, and sliced bread. Okay. So, huh?
So we've got the oxygen.
It is more important than oxygen. All right. And yeah, oxygen maybe. Okay, so we're going to be talking about agentic design patterns. Now, this is a little weird, right? Because it's kind of a concept that I came up with by mistake. Then I shared it, and everyone's like, holy shit, this is cool. So that's the reason I'm sharing it with you. All right. There are GitHub repos that you can go to and download this stuff. Probably tomorrow or the next day when I upload everything. So I'm hoping that you find this useful. Also, if you really want to, that's my website. So chrishuntingford.com, Agentic AF. That's architectural framework, not the thing that you were thinking. I kind of stole the AF from Andrew. It's a long story. Anyway, yeah, so there's a whole bunch of stuff in there. I'm doing a bunch of YouTube videos, so hopefully you guys will like it. There's a ton of work that's going into it. And also it's because I've been doing a lot of work with Microsoft directly, a lot of work with partners and customers all over the world. And I've had some pretty scary lessons learned. So I'm going to impart those with you today, if that's cool. All right, so let's get going. I just want to quickly talk about what an agent actually is, because I think if you ask every single person in this conference, what is an agent, you're going to get a different answer, right? And it's real interesting because some people are like, oh, it's a really glorified workflow. It's workflow with AI. It is really not any of those things. There's a ton of bits and pieces that make up an agent. So what I did is I thought, well, being a nerd, I'm an ex-developer. I'm better now. And sorry for the dance. A lot of folks think that like AI is just generally nested if-then. Okay. And it really isn't. There's a bunch of stuff that happens underneath the hood. So I want to break it down for you. An agent, first of all, is an autonomous system, typically, right? So it's something that is going to live in the background. It is a system, though. It's a collection of things, right? That's really important. So don't see an agent as one thing. It's a collection of things that work together. The second thing is it perceives its environment. It understands where it is and what it is, typically. Okay. So typically what will happen is when you create the system, it understands its ecosystem. And the reason it does is because you give it things like instructions and data. Okay. The next part that's pretty important is that it makes decisions. Now, again, it makes decisions because you give it instructions. You give it the ability to choose, essentially. Now, that's a little weird because generative AI is very non-deterministic. Now, we're going to try something, okay? And this involves audience participation. It's a really rainy day in Piran, and you're going to have to complete the sentence for me. Let's go to the pub, okay? It's a really sunny day in Piran. Let's go to the pub. Okay, fair enough. And that is very non-deterministic. Now, when I tried this in the UK, the answer was beach. I'm like, you British people go to the beach? What do you do there? But it was really interesting because it actually can be very non-deterministic. So in my brain, I was thinking, hey, you guys might say beach, you guys might say the concert, you guys might say the pub, I don't know. But it is non-deterministic, okay? And it makes decisions based on knowledge and information that is shared. Now, here's the deal. Me, I'm a very deterministic human being before I drink tequila. After I drink tequila, I am non-deterministic. That means anything could happen. And that's a bit like agents. And the last thing is it acts to achieve a specific goal. Now, that is a good agent. And a lot of the time, I don't think we give agents enough goals. I don't think we give them enough guardrails. Okay. So a good agent acts to achieve goals. So it's like, okay, that's cool. That makes sense to me. So this is kind of the core academic definition of what an agent is. When I started to look at what Donna's team had done around like AI for agents and how to get started, there's a really good URL. So it's aka.ms.ai-agents-beginners. It is not for beginners. I will tell you that. It is very high code. There's a lot of reference to things like Semantic Kernel and AutoGen Studio. But actually, what's really important is an agent has an engine inside of it. And that is called a large language model. Okay? You all know what that is, so I'm not going to go into huge detail. But effectively, the LLM, the large language model, provides the engine for the agent. It provides the thing that makes it run. Let me ask you a question. How many of you in this room own a car? A few of you, right? When was the last time you opened the hood to mess with the engine of the car. I don't remember the last, you at the back, you've done that, right? Yeah. Very few of you, right? How many of you make LLMs from scratch? A couple of you maybe. But I can tell you that a lot of the time we don't actually need to see the engine. We don't need to see the thing that makes it operate just like a vehicle. Agents also perform actions. It's very important. If it doesn't perform an action, it is a copilot. Okay, an agent performs an action. It does something, right? It has access to tools, which you will see today. And it also has knowledge. So that's really important. Now, a lot of us talk about the fact that, hey, we've got workflows and I put AI into my workflow, therefore I have an agent. That is not true. Okay, one does not just simply inject AI into a workflow and call it agentic. And the reason for that is because it is very much deterministic. Okay, it follows a path, whereas an agent doesn't necessarily do that. And we're going to show you that just now. There are also lots of different types of agents. Now, I know it is going to be very much impossible for you guys at the back to read this, so you will get the slides. I was kind of hoping for a giant projector, but we have tiny TVs, so we're going to roll, right? But basically, when you look at the types of agents you have, there's very many different kind of layers to this, all the way from like single, what we call reflex agents, or declarative agents, things that just give you data. So they use a thing called retrieval augmented generation, and it will give you information, all the way down to what we call an agent mesh. Has anyone ever heard of that? That is cool, right? You see, you've heard of an agent mesh, okay? Some of them call it a multi-agent system. There's lots of different terminologies for this, but an agent mesh behaves very differently. So what I did is I thought, well, I'm going to kind of draw this for you guys because I prefer something pictorial. Now, at the moment, we're very good at building what we call singular agents that behave in their own ecosystem. So these agents are singular. They have their own set of knowledge. They don't necessarily talk to other agents, but they typically live within their own ecosystem, and that makes them much easier to govern. Okay, so in this room, how many of you have actually built an agent before? Yeah, most of us, right? And a lot of us have built these singular agent systems. Where it starts getting really weird is when you get these multi-agent systems, and this is what we call an agent hierarchy. Okay, now this is also very much still living within the governance layer because you can track and manage what that agent does. Now think about this. When you do an evaluation, how many of you do evaluations in red teaming? A couple of you, right? Yeah. Okay. So when you go through the process of testing, you're testing singular agents. You're testing one at a time. You're evaluating one agent at a time. But what happens when you get to this world over here? Now, this is where it starts getting weird, and this is called an agent mesh. Now, this is what every partner under the sun is saying they're doing. I would like to know, has anyone ever built an agent mesh before? You will have definitely. Anyone else? No? Okay. So when Microsoft talk about this concept of agent to agent, they talk about agents communicating with one another, all right? And this is what everyone is trying to do, all right? I would love to know if anyone's put one of these in production. And the reason this is very difficult from an architectural perspective is because you don't know how the agents are going to connect with one another. It's not like integration. It's not like automation. So what's crazy is that if this agent on the left does something and that agent on the right does something, what happens? How do you know that they're going to interact correctly with one another? And I'm going to show you this because it gets really weird really quickly. Okay. So a couple of other things. There are some pretty epic tools in the Microsoft stack that we get to use, all right? And I do feel like, for me, I'm ex-Dynamics, ex-Power Platform, now do a lot of data and like specifically towards things like Foundry with AI. I forget that there are a lot of tools in the stack, okay? Now, the example I want to give you is, think about it like this. How many of you have ever played Lego before? Yeah, you all have. Yeah, and not just with your kids, on your own. And what's cool is that when you open up that box of Lego and you chuck it all out on the rug and you build something, right? You're not using the same brick every time. You're using different bricks, right? And that's a bit like the Microsoft stack. It's this interlocking set of digital bricks that you can use consistently. And what they do is they build these things out so they do clip together. So I am a culprit of this. I'm like, okay, I'm going to solve everything with Copilot Studio, right? Everything. And what it turns out is I can't. I just can't, right? So I've started learning cross-stack how these agentic tools work together. And there are some very good examples of this. So I'm going to run you through a couple of them, right? Firstly, I don't know what it is, the animations on this slide, so I apologize because that is hilarious. Firstly, the layers of AI. We talk about three different layers. We talk about embedded AI. That is the first layer of AI. Embedded AI you are all using today, okay? So Microsoft 365 Copilot, AI in Microsoft tools like Dynamics, so BC and CRM and finance and operations, whatever we're calling it this week. But what's important is that you're using those tools. You don't need to reconfigure them. That is embedded AI. That is AI that exists in product. I will tell you something. We've been using embedded AI for a long time. How many of you know about this tool? PowerPoint. There's this button in PowerPoint that when you click it, it makes your slide look worse than it already did. It's called Designer. Yeah. That is embedded AI. We've been using that for years. So don't think for 1 second that you're not using it. It's been around for ages. Then we get extensible AI, and this is really where I love to kind of get stuck in, right? And extensible AI is really around the Power Platform. Have we got any Copilot Studio people here? You have to put up your hand. So Copilot Studio is really one of the coolest set of tools that I've found. And I'm going to give you, test. Can you guys hear? Hello? I'm going to give you a quick peek. This is the testing of the presentation. Come on. There we go. Yeah. All right. So this is a tool called Copilot Studio, and Copilot Studio is effectively embedded in the Power Platform, and it allows you to build these really cool agentic systems. Now, I'm going to show you guys a multi-agent system later, but I wanted to give you a quick peek. So Copilot Studio effectively added to the Power Platform, which was the conversational user experience layer that we would have to interact with data. So I'm not saying apps are going away. They're definitely not. And I think if you went to April's session, you would have seen that. But what I will tell you is the way in which you're interacting with data is really different. So Copilot Studio provides you with this interactive layer that you can use to talk to data. Okay. So if you've never used it before, I highly recommend. It is probably one of my favorite tools to start building out AI. But what you do is you use Copilot Studio to extend the embedded AI layers. So my example is, if you have tools in your finance and operations products or your dynamics products, and you're not happy with the AI is working, the way the AI works, you can build out more layers using tools like Copilot Studio. Make sense? Sweet. All right. And the last one I want to get onto is to quickly give you a peek at something else. I will go into much more detail on demos very shortly. Yeah. And the last one I want to get into is differential AI. And this is really important, right? Differential AI is what everyone is talking about. They're like, we are building differential AI into our business. We're making LLMs. But why? Because you haven't figured out how to use the basics. You haven't figured out how to use the embedded AI tools. Isn't that wild? So we're also busy making LLMs and training models and doing all this crazy stuff, but we haven't figured out how to use embedded AI or even adopt it properly. So just a quick show of hands in the room. How many of you use tools at Microsoft 365 Copilot? Yeah, loads of you, right? There's loads. What I've started to find is that even just adoption programs in Microsoft 365 Copilot are really hard. Teaching people how to prompt correctly is really difficult. I often say to people, I believe that we're in this era called the solitaire era of AI. Now, here's a question. Microsoft doesn't know a lot to answer this. Do you know why Microsoft included solitaire in Windows? You can answer, but you know this. Okay. Why?
To train us to use a mouse because a QWERTY keyboard is a typer.
That's correct. So it was there to teach you how to use a mouse. Embedded AI tools like Copilots are there to teach us how to prompt. We're learning. We're in a learning phase. We're not experts. I mean, somebody said to me the other day, they were like, hey, Chris, can you recommend a prompt engineer? I need them to have 10 years experience. And I started laughing. I'm like, dude, yeah, for sure. Can you speak natural language? Right? So I found that really interesting. What I also find interesting is the movements of where we are versus where we've come from, right? And what I'm starting to see is that tools like Copilot Studio and tools like Foundry cross the stack. You can use them if you're a pro dev or not a dev at all, right? I haven't written code in a long time without vibe coding. And what's interesting, and I used to work for Borland, right? The people that wrote Delphi. So any of you nerds out there that have used Delphi or Turbo Pascal? Yeah, I used to work for them. It was weird. Yes, at the back. You know what I'm talking about. Yeah. And it's interesting because the way in which we're starting to perceive these tools is different. I, Chris, a non-dev, am starting to use tools like Foundry in my day-to-day. Isn't that cool? And I will talk to you more about what these are. So what does each one do? So let's talk about this real quick. When you start thinking about tools like Azure Foundry, it's really a great way to build out these really unique agentic experiences that are very difficult to create within low-code tools. So the example I will give you is one of my customers, and this is a real story, is the police in the UK. Okay. And the police in the UK need us. They basically have a database. It's called the Policing National Legal Database. And what these people do is they store every piece of arrest information you can find in the country. So go to the dark part in your brain. That's the data they have in there. It's really creepy. So I spent a lot of time asking those AI models intensely difficult questions in my red teaming processes. You cannot use Copilot Studio in that scenario. And the reason is because Copilot Studio's responsible AI filters are really high. The content filtering is really high on purpose. So I use Foundry because I can drop those content filters and even get an exception. But what's important, and this is a real story again, like I'm not obfuscating any of the data, is that a new police officer was using one of the tools. They asked the tool, this is not using Foundry, this is using a legacy AI tool they had on top of this data. They asked the question, what is the legal load that a lorry can have on the highway? And it came up with porn. Okay? With porn, P-O-R-N. Yeah. Well, the description of porn. Yeah. And it was telling them all about it. Isn't that crazy? That's what these tools do. They're generative. This was not a Microsoft tool, just letting you know. We've replaced that since, by the way, with a Foundry agent that works super well. So when you start moving down the stack, tools like Copilot Studio are excellent for kind of those rapid agentic builds. So if you start thinking about like getting to value really quickly, Copilot Studio is a brilliant way to begin, right? It's a great way to build out these agents really quickly, and I'm going to build you a bunch today, all right, without low code. But what they do really well is kind of augment workflow, not process. Process is linear. Workflow is not linear, all right? And I'll show you that. We have M365 Agent Builder that's ingrained inside of M365 Copilot. That's really good at building those very basic reflex agents, okay? Singular point and shoot agents. And then finally, my favorite one of all is the data fabric agents. Has anyone ever heard of this before? There is an agent that lives in a tool called Fabric, and what it does is it actually brings your data to real life. And EO1 actually just recently built one. Yeah, it was very cool. So I've given a breakdown of each of the tools, what they do and how they work, all right? And I'm not going to read this all out to you now, but there are differences. And I always say, start with either Copilot Studio or Agent Builder and then work your way up, all right? And often when we do our delivery, so Andrew, Anna, and I do a lot of work with some really crazy customers, we often build varying versions of each agents and then pass it upwards. And in fact, one of the most recent ones, we built Foundry and Copilot Studio. We had great results in Copilot Studio. Foundry wasn't as good, and it's just dependent on the job. So here's something else important. An agent makes up parts of the workflow. It is not the full workflow. And this is key, right? So when we start thinking about like what we do as humans, I did steal the slide from Donna, and I don't feel bad. But we always think a process operates like this. You have a bunch of people working within the process, and we think that actually what should happen is the agent should replace the person, which is not true. When you actually start thinking about it, the agents replace the task. It is not the full workflow. And this is where we make mistakes, friends, from an architectural perspective and an agentic design perspective. We're so fixated on replacing the process end to end with the agent and not the task. Okay. And actually, Anna and I did a really fun experiment recently with an organization where they said, we would like an agent to help us practice our soft skills. Just be careful, don't do this. And if you do, you need lots of rye. We actually made them role play the tasks. And then once they'd done that, we said, okay, which ones can we replace with agents? But the person is still really relevant, right? Now, this extremely detailed slide I spent hours on shows a business process, not a workflow. Because remember, business process is end to end. Workflow is not linear. And actually, when we start thinking about the agentic flows, we don't replace the whole process. We pick parts of the flow to replace. Isn't that interesting? And I think what actually we struggle with in the design, in agentic design, is we're so busy replacing everything, not pieces of it. That's the problem, right? And I will show you how this operates. I just need to make sure I don't go over. Another weird thing is, I don't know if you have this in any parts of the world. In South Africa, we have this really weird saying. It says, we don't eat the elephant all at once. I don't know if anyone's ever eaten an elephant, but whatever. But the point is like, we need to start thinking about taking bite-sized chunks out of our workloads, not the full workload. And that's the real key to agentic architecture, is not replacing the full workload. Okay. Also, when planning to build your solution, and I'm a culprit of this, you'll go through the process of, hey, how the end user wants it and what we actually built, right? And this is typical of agentic AI. I don't know how many of you have experienced this, but like I've built an agent really recently for an oil company. And they said to me, Chris, it's not giving us the results we need. And I'm like, because it's non-deterministic. And they're like, yeah. So I'm like, so yeah. And then we grounded it in good data and everything was better. But the point is that it's not going to operate the same way as it always did. Processes are not going to work the same way as they always did. And this comes down to educating customers and saying to them, look, folks, with agentic solutions, it's not going to be the same. It is going to be different. It's not always going to give the same answer every time. It might be like 10% off, but that's got to be something we deal with. And I'm sorry, it is generative AI. What does it do? It generates, okay? And that's by design. So now we're going to get into the nerd part. Everyone ready?
Yeah.
This is going to get nerdy. Okay. So there's a big difference between technical architecture and agentic architecture. So how many architects do we have in the house here? We've got a couple, yeah, a few. I know some of you by very personally, and I know some of you are like hyper good at what you do. I don't know the rest of you, and I'd love to, so please tell me. But there is a difference, right? And the difference is technical architecture is about what runs where and how. Okay, what are the tools that are running and where are they running? I am 1,000% not taking credit for this next slide. This was an Andrew and Anna job that I bastardized and added a lot more color to. But this is what you call a notional ecosystem design diagram. Okay. And what I like to do is, and we like to do at least, is walk into businesses and say, hey, like, what does your ecosystem look like? What does the whole ecosystem look like? And we build these really kick-ass designs. Theirs are way better than mine. I am very much a practical human. I have a lot of talent, but very little taste. So my designs are not as great, but what's important is that these technical designs are really key in going through this agentic process. So what you're going to find is that organizations will have layers of tech that you can already use. So some of the orgs we work with have Amazon, some have Google. And that's cool, right? Because a lot of these stacks work together. But for me, I'm focusing on the Microsoft stack. I hope that's all good, right? But when you start drilling into it, actually, what does this mean? Now, when we build out architectural designs, typically you're going to land up with something like this. So I've seen tons of these shared on LinkedIn. People are like, hey, we made an agent flow. And I'm like, cool, that's awesome. But do you know what? I got feedback from a customer the one day. They were like, Chris, why is the big colorful box so big? And I'm like, well, it's trying to indicate that there's a lot of shit in there, right? Like there's a lot of stuff in there. And they're like, okay, cool. I'm like, cool. And then it got kicked out by security and compliance. Compliance was like, this is not happening. And the reason it's not happening is because we don't know what's in there. So I'm like, okay, this is a good point. So what we got to do is we got to think about who decides and acts. And that is agentic architecture. It's really the underpinning of what happens inside the agentic tools. Because I could have 50 agents running inside of that Copilot Studio box. And guess what? My architecture design does not talk to that. It does not show that. It does not reflect that. And that's why compliance will never let me publish that agent. So what you've got to do is you've got to start thinking a little bit more. So this is actually drilling into the box. Now, this is an example of what I call an agent hierarchy. So remember those designs I showed you guys earlier? An agent hierarchy has an orchestrator agent. That's the boss, okay? So in my world, Anna's the orchestrator, right? And it's important because Anna kind of has a team of people who do a lot of stuff with her. And I'm not saying replacing people. Remember, replacing tasks. Protect people, not jobs. Important. So the orchestrator then handles what the other agents are doing. So as you can see, I've got a planning agent. That planning agent has documentation as knowledge. I have a Q&A agent. I have a data capture agent. I have a review agent, and all of these agents work together in this agent mesh. So when I pass this back to my customer's like, oh, that's pretty cool, man. Like now I can see the agents that exist in here. I understand that you're using MCP servers. Just putting a box with a bunch of lines on it doesn't help. You have to be able to articulate what the agents are doing. And in this new world of agentic architecture, this is going to be critical, okay? Here's something else crazy. What do all agents have in common? They have a description. They have instructions, okay? I'm a solution architect. My job role says X. I'm the chief AI officer. My job role says Y. I have a description. I have instructions, Okay. So what I've started to see, and you will start to see this as well, if you're digging under the hood into things like Agent 365, is that the agent IDs are managed the same way as a person's ID. Isn't that wild? Inside of tools like Entra. Okay. Remember, we're not replacing the person. That's important. It's replacing the task, rethinking the task. So going through this process, I'm like, okay, that's pretty cool. What does this look like altogether? And you have this much prettier design around a fully fledged agentic architecture, both technically, but also you can actually see the agents that are in the architecture. What has to happen underneath, though, is that when you provide the information to your customer, you have to literally make a list of the agents that you built. You have to say, this is my planning agent. These are my instructions. This is what it does. This is my orchestration agent. These are the instructions. This is what it does. Everyone good? Okay, so you can use this template. It works pretty well. I'm still working on a template for the actual instruction planning. There's a bunch of stuff under there that hopefully we'll be able to release. But it's very cool because it shows immediately to the people that are getting the agents what it looks like. Now, I'm going to show you guys an interesting thing. Recently, I was asked to build out a multi-agent system using mixed technology. So I thought, okay, cool. So first things first, I like to use Microsoft Fabric. It's my favorite place to put data inside a lovely, beautiful little warehouse. I use it to store a ton of information. Now, Fabric is excessively powerful because it rolls data from across the organization into one place. Isn't that cool? But as you all know, AI is not actually that good with structured data. It loves unstructured. Generative AI loves unstructured data. However, the Fabric data agent loves structured data. It's very good at it. Okay. Then what I did is I built a Foundry agent doing retrieval augmented generation against that data. I finally plugged that into into Copilot Studio and then surfaced that up directly into M365 Copilot. And that is using every area of the Microsoft stack to surface data upwards. And the reason I did that is because there were layers of data that needed to be stored in different places, and the agents needed to behave differently as well. Let me give an example. The reason I used the Foundry agent in here is because the data being surfaced through the Foundry agent was much more sensitive. It was that policing data. It was much more sensitive and way, way more kind of, I would say, detailed than the data that was being surfaced through the Copilot Studio agents. But they work together to provide me a single point of touch where these agents, these multiple agents, live under the hood and do all the work. But I simply interact with one interface. How's that sound? Do you guys want to see this in practice? Okay. So what I did is, given that we have space theme, I kind of went and decided, to do another architecture. Now, I will tell you something a little bit nerdy. In my pastime, I've taken a bit of a break now. I study planetary sciences at the University of Birkbeck. And one of the subjects is astrobiology. No, I do not believe in aliens. Well, actually, I believe in the Fermi paradox. I don't actually know if they exist or not, but whatever. But what I did is I built out a whole data set that talks to me about UFO spottings around the world. And it's actually real data. It talks about where UFOs have landed most, why they've landed there. And yeah, I've got a ton of information that I rolled up into an actual agent to help me do my stuff. Okay, so I'm going to show you something quite cool. This is how we see if I can use a touchpad properly and speak. Okay, so I'm going to show you guys something. First of all, I'm going to show you what it looks like in a tool called Fabric. All right. So over here, I've got a workspace, and you can see it says Astrobiology Demo. This is rigged up to a very, very cheap little Fabric license that I've got ticking around in the background. Okay. And what I've done is I've roped a ton of data into my data warehouse over there. So you can see it's very simple UFO sightings. You can see that there's a ton of information about those UFO sightings. Okay. It's all historic, and they all live in Fabric. The reason I've chosen it is because I get updates on these UFO sightings when some crazy person sees an alien. Okay. Some of you will see those tonight, by the way, if you drink the vodka. Anyway, yeah. So I decided to store it in there. So effectively what I've done is I've gone and solved the Fabric problem. I've got a bunch of data in there. Now, something that's important, and Ioana and I have gone through this very recently. When building these agents out, right, like it's very hard to connect this Fabric data up into a Copilot or an agent. There are lots of things like connectors, right? So you could use the SQL connector inside of Copilot Studio, but I've personally found that there's limitations on the number of records that get shown. Okay. So actually, how do we do this? So what you've got is you've got the ability to build out a thing called a fabric data agent. And this is by far one of the coolest pieces of functionality that Microsoft have released. So I always start with data, by the way. I always start with data, and I always make sure that I've got the data in Fabric or Dataverse, one of those two places, and I always pull that data up to the top layer using an agent. So the right way to do that, and what I found as best practice, is you have the Fabric data agent. All right. Can't spell agent. There you go. It's come out of preview, which is very cool. And what you can do is, whoa, we're not happy. There we go. What you can do is kind of connect it up to the data source that you want. So we'll call this DA_1234. Random name, I know. Security, naming conventions, rock solid. And it's going to build me this agent. By the way, everything I'm doing in this demo is 100% live, right? I pre-prepped, so I've got some stuff kicking around in the background when things break, but it is live. You're going to go ahead and add your data source. This is really important, right? So you can see I've got a ton of them here. Here's my policing data over there, which I might show you given if we have time. But I'm going to connect it up to my UFO sightings data. So I'm linking it up to the data warehouse. And what it'll do is it'll surface the data over here, and I simply select the one that I want. Okay. No, I do not want to tell my friends and family about Power BI. That is a weird conversation to have, Microsoft. Okay. So what I'm going to do, now this is probably the most important thing. With this agent, remember, do we have any Power BI people in the room? Any data people in the room? Okay, very few. So in Power BI and in Fabric, you get a thing called a semantic model. And what that is it kind of tells you how the tables are all connected, all right? The data agent doesn't do that. It doesn't know how the tables are connected. It doesn't reference that. Isn't that wild? So it talks directly to the data. So what you have to do is in your agent's instructions, in the Fabric data agent, is you have to tell it how these tables are linked. Isn't that crazy? So I'm not going to go ahead and I'm not going to productionize this one, but I'm going to show you guys one. You literally have to tell it. If you don't tell it, and if you ask the agent questions, it's not going to know that table A is linked to table B. It doesn't understand that. So Ioana and I actually did this recently where there was a whole structure that you were building on, and you ended up having to basically tell the agent, give it a data dictionary, say, this is what this column does, this is what this column does, this is what this column does. It's smart, but it's not that smart, right? And then tell it how the tables actually work together. Yeah, without it didn't work, right? See, okay, so when you do this, don't make the assumption that the agent's going to understand everything in the database. It doesn't. You have to tell it that. So the example I will give you is if I go to I'll see if I can open it up. Let's go back. I'm going to create another one. Oh no, it's closed. Okay. Sorry, folks. This touchpad is a lot of fun. Let's grab it over there. Fabric trial. Fix that one. Nope. Oh, no, I'm not having. Okay. Well, I'll show you the data one that I created already. Okay, so here's the data agents I've got. It's DA astrobiology. And in the instructions, you literally have to tell it what's in there. So again, remember, tell it, give it the table name, give it everything it needs. Because if you don't, it's going to make up the most random stuff in the world. Okay, so what I've done is I've literally created the data agent as the very base. So I've got something that I can talk to. Now, what's cool is you can actually publish this data agent directly. Whoopsie. You can actually publish this data agent directly to M365 Copilot if you want. So if I go into Copilot over there, there's my policing data agent there. So if I ask it a question, how much? I don't know what it'll come up with. It's, remember, non-deterministic. It may fire something up, but this is actually looking at a bunch of UK policing information and it'll pass the information back up to me. But only because I've shared the right information in the background, okay? Yes. Oh, well, it's giving me a bunch of random stuff. Anyway, whew, thank God. None of my stuff's in there. Cool. So the Fabric data agent's there. The next thing I'm going to do is I'm going to go and actually build out a Copilot Studio agent. Now, because of time, I'm going to show you one that I've already got. Okay. So the first thing that I did, and this is hyper important, please, again, this is the second thing I'd love for you to take, is that I've called this UFO sightings tracker. Okay. It's got a description. The description is really important. Okay. Please remember, this description is used by other agents. So if you build an agent mesh, it looks at that description. So if you call it Bob, it's not going to make any sense, right? It's not going to call it. So that description is really key. The next thing that's really key is your model selection. In Copilot Studio, if you turn on the Claude models, you've got a bit more, but you only have like 10 models to choose from. In Foundry, you have 11,000. Okay. There's a big difference, right? So Foundry, if you want the depth in the models, you've got to use Foundry. If you want to use the base models, you've got to use Copilot Studio. The next thing that's hyper important, right, is I've given this a set of instructions. Again, incredibly important. Your instructions matter. This is where I'm going to tell you that it starts getting scary. How many of you remember building websites using tools like Notepad? Okay. A lot of us have done it. Do you remember how hard it was to debug? Like you would publish up to IIS and then you would see that your div tags were wrong and you'd have to rethink that. There is no way for you to run these instructions through syntax. So if you spell something incorrectly, it doesn't care. It's going to obey those rules. So what do? There's no best practice. There's some good practice, but there's no like best practice. So what do? It's natural language. That's tough, right? There's no way to say these instructions will work the best in this scenario. We're back in like 97. We're debugging by hand. I think somebody will invent the agent instruction syntax model at some point. If anyone wants to make $1 billion, do that, right? But for us, we don't know. So when you're testing and I remove that full stop just from over there, if I simply do that, that will make a difference in the way my agent responds. Isn't that wild? So what's going to happen when you have an agent linked to an agent? And then you change the instructions in that agent. What happens here? Have you guys thought about this? Because this is a governance problem. So what you have to do is be hyper-specific in the way your agents operate. If I show you the mesh underneath this, you can actually see, I'm going to discard those changes. You can actually see I've got 5 other agents. Okay. I will tell you, I tried to connect to Foundry. I have got an error, so I'm not going to show you that. But you can actually connect out to other tools. So let me give you an example. Add an agent, connect to an external agent. You've got your data fabric agent over there, which I've already pre-connected. And then you've got your Foundry agents as well. So these work together. So what can happen is you can use Copilot Studio as your orchestration layer and connect all the other sub-agents up into that if you don't want to mess with orchestration. Okay? Very important. I'm not hyper sure of the orchestration protocol that Copilot Studio uses. I don't know, April, if you know. But they've got like all sorts. You get linear orchestration, Agentic orchestration, group chat orchestration. I think it's probably group chat. What that means is it checks the agent's descriptions and then passes to the right agent. But what happens is that I've roped all these kind of different agents up there. You can also see I've got a Q&A agent. What this will do is ask me a bunch of questions based on the fact that I've seen a UFO. Okay? Again, my description is really important. My instructions are really clear. So when you build these out, it's not a 5-minute job. You have to spend time on setting up the description. You have to spend time on the instructions and always, again, referencing your agentic architecture every single time because this matters. And what I found is that actually I've ended up changing these most of the time halfway through because I add new stuff. But let me give you guys a quick peek at something. Okay. So if I go back to my actual agents, my orchestration agent. So what you're looking at here, the main global UFO sightings tracker, you're looking at the main orchestration agent with a bunch of child agents. Let's ask it a question, right? So I'm going to go into my test pane. You'll see on the left-hand side, you'll be able to track what the agent's doing and how it's doing it. So I'm going to say, tell me about the Fermi paradox. The Fermi paradox basically is in astrobiology. If aliens exist, why haven't they visited us? Go to Reddit. If you saw Reddit, I also wouldn't visit planet Earth, right? But what it's going to do is it's going to try and pick the right agent. So you can see it's going through this group chat process. It's gone through work IQ. Now it's gone straight to agent number 4, astrobiology agent. And it's going to pick that one and actually answer the question. Okay. This is what you call agentic turns. So every time it passes off to a new agent, that's a conversation turn. And what it'll do is it'll spit the information back out to me. Now, something to remember, if you overload the orchestrator with too many agents, it will be slower, like a lot slower. Okay. So what you've got to start doing is thinking about how these agents will interact. So you can say, you can see it's basically giving me a ton of information about the Fermi paradox. I can say, make me a report. And what it should do is pass on to agent number 5. It'll build me the report that I can download. Okay. So that's pretty basic stuff, right? Now, what's interesting is that these agentic turns are really cool. I've got a bunch of tools in here. You can see that I've got Microsoft Word. I can go and download the Word report and, obviously email that to all my friends to tell them about the Fermi paradox, which is boring AF. But what's cool is that you can see the conversational turns are being managed in the agent. This is based on my agent architecture. So we do something a bit more fun. Okay. What if I want to capture data? What if I want to bring data in? I'm going to say, I saw a UFO. Okay. If those of you that were here on Sunday nights, I felt like I saw a UFO after all that vodka, let me tell you. When did this happen? Today. In Piran. Buzz off. Where did you see it? In Piran and Kibbutzim. I saw a giant red ball of light. Okay, it might have been the tequila or that drumming stuff on stage. That was crazy, right? Now, what it's going to do is it's going to flick back to the Q&A agent. Do you see that? Again, a conversational turn. It's moving between the agents, asking questions. This is how it should work, right? It's non-deterministic. I don't know what it's going to pick, remember. But what I've done is I've been super clear about the description in each agent and super clear about the instructions, okay? So let's check out what it's doing. What time did you see it? Midnight? I guess that's when the tequila kicks in. Can you describe its shape more clearly? It was a triangle. Approximately how big did it appear? It was huge. Yeah, triangle ball. Yeah, have you never seen a triangle ball? Yeah, jeez. Approximately how big? Did you take notice if it was one object or multiple? It was multiple triangle balls. There we go. Now it's going to carry on asking me questions until it's got its own clarity, right? So there, Joanna, hope that's okay with you. It's going to ask me a bunch of questions based on the fact that it's going to look for clarity and then move on to the next agent when it feels like it needed. Was it moving? It was moving. I saw it for 5 minutes. It was going north. I don't know where north is. What weather was it? It was warm. Jeez, this thing's getting personal. It's going to ask me what I'm wearing next. Oh, I broke it. Okay, fantastic. Again, non-deterministic, right? Like, this is why we don't put these things in production straight away. This needs to be red team. But if I actually go back and I take a look at the activity, you can actually see that there will be a conversation chat that you can review, right? So that depending on the number of turns, this one was quite a good one. Depending on the number of turns, you can actually see what it's done, where it's put information, and. So you can actually see over there. Cool. Oops. There we go. This is the number of turns. So you can actually see the full conversation history and what's gone on. Now, what's really cool is that in the background, I have an MCP server. It uses a tool called Dataverse. So those of you that may or may not know it, Dataverse is the world's most powerful data structure. And those of you who like Dataverse, I have a Dataverse tattoo. So when you go to Vegas, don't do dumb shit. Right. Anyway, back to the gist. I'm using a Dataverse MCP server, and when I ran my demo earlier, my little test, what you can actually see is that it did capture the data, including lat and long, and it did capture a bunch of information. Apparently, it was in the shape of a sea turtle, so that was a little weird. But what's cool is that the data from the agent works directly against the data structure. So effectively, all I've done in this very cool little agent setup is I've rolled together a number of agents and a number of tools in what I call a hierarchical agents, and I'm using that agent as the front facing for my users to interact with data. Okay. Very important. You can publish up to Microsoft 365 Copilot. So eventually that will land up in here, okay, after a little while, and your users can access it directly through the M365 Copilot interface. And what's also very cool, folks, is that eventually this will also land up in a tool called Agent 365. Which now I'm just pressing buttons. And Agent 365 is your central place to manage all agents within your company, even agents outside of the Microsoft stack if you want to. And what you can do is you can go ahead and reference those agents and interact with them as a basic agent registry. And there's my agent over there, Astrobiology 001. Okay. So to kind of bring this to a bit of a close, right? Because I've gone through a lot of tech. I want to show you one last thing. This is a multi-agent system for a legal firm. And there are 11 agents in the system, okay? And this does ideation, capture, and management. And what this does is it actually takes you through the process of capturing an idea. It architects the full idea using Microsoft technology, and it actually captures that all into a data structure. there's something that happened here, and you can actually see one of those agents is turned off. Do you want to know why? This agent was gaslighting the other agents. It's crazy. What it was doing was I put a description in there with a bunch of basic demo information saying this is what the data should look like. And every time the data got captured in the data structure, this thing would review it and not be happy with it and just say it wasn't perfect because it didn't match exactly. My instructions were bad. But what's important is agents do gaslight each other. They do fight against each other, and it's really funny to watch. Okay. So when you do this, you have to be super clear, again, super clear about the description, the instructions, and the tools that that agent is going to use, because they will fight against each other. Is everyone good? Okay. So this one I'm not going to demo to you. It's quite a long one, but something that is also very cool just to show you is that these agents on average do around 15 turns. So they do about 15 turns. This has taken us 2 months to build, by the way. They've done a 15 turns, and you can actually see the process. Look at that. It even scores it based on the Gartner scoring quadrants. This is very cool. It took a long time. Agentic design is not simple. Okay. So what I would recommend you do is those of you that are on the more technical side, start learning how you can translate that into an agentic design, thinking about the types of agents you're building. And if you're non-technical, even better, because you are actually very well positioned to start doing agentic design based on those descriptions and those instructions and how these agents work together. Everyone good? Okay. Oh man, I'm so jealous. I want to go play drums. It'll be so fun. So last thing. Yeah. So last thing. I would like for you guys to think more clearly about the architecture, think more clearly about the agents you need, the number of agents and why they're there. And again, friends, please just hit me up. Go and check out the webpage. I will be adding content. And also, there's a form in there to submit ideas if you have them. Please do it, and I will architect them for you and show you how to do it. Okay. So I'll take questions after this. Well, thank you very much.